5 stays in front. I have t to the third minus t minus 1 minus 3t to the third and plus t. Everything over t cubed minus t minus 1 squared. So then 5 can still wait patiently. I have negative 2t to the third. These two go away, and minus 1 over t cubed minus t minus 1 squared. I wouldn't even bother to put that in. I will leave it as negative 5, factor out negative 1, 2t to the third plus 1 over t to the third minus t minus 1 squared. Yes, some of these problems can be involving, can be hairy. Yes, I agree. So I distributed negative t times 3t squared and negative t times negative 1. Luckily, these two went away. These two combined make up a negative 2t cubed, and then minus 1. I factor out negative 1. I keep the negative in front of the fraction line. 5 can stay in front, or you can put it at the top, but not in the denominator. This is not 1 over 5, right? It goes back where it came from, and this is it. Why is this so important? You will see in chapter 4. And what do we do with this in chapter 4? Any questions? Any questions on any of the steps? Okay, let's continue practicing. Product, quotient, please choose. I'll go slowly till the end and then I'll come back. Again, here they're asking us to find the first and the second derivatives. Of course, this will take much longer, especially on a rational function. Of course, they will.
33.
Yes. So you want to determine the first and the second derivatives on 33. Yes?
Yes.
Okay, perfect. So again, we'll come back to this in a jiffy. So again, the equation of the tangent line. Find the equation of the tangent line and normal line. I'll explain what the normal line is. So let's go back and work on 33.
And normal line.
Yes, you wanted me to explain the normal line? Somebody said something about the normal line? Anyone? What was the question on the normal line, please? Okay, so I'm not sure what you wanted to say, but so if this is a function at this point, there are two important lines. One is the tangent at that point, and the other one is the normal line, which is perpendicular, 90-degree all around, 90-degree angles all around. So this is the normal line. This is the tangent line. The green one is the tangent, and the orange one is the normal line. Is the line that is perpendicular to the tangent line at that point. Okay, so we wanted to look at, I think we said 33. And we have f of x equals x over x squared minus 1. And they are asking us to find the first and the second derivatives. Okay, so for the first derivative, I know it's the quotient rule, so I have x squared minus 1 squared in the denominator right away. Can anyone tell us the derivative of x? What is the derivative of x? We should not think about the derivative of x.
1.
Yes, times the denominator, minus the numerator, and now we need the denominator prime. Can anyone give us the derivative of the denominator? So I can put it here.
2x.
A sip of water. Sorry about that. Indeed, 2x. I'll try to see if I can simplify it. So I have x squared minus 1 minus 2x squared divided by x squared minus 1 squared. So of course negative x squared minus 1 over x squared minus 1 squared. I don't like those negatives. X squared plus 1 over x squared minus 1 squared. This is what I want to differentiate to find the second derivative. Negative 1 can stay outside as a constant, a factor. The denominator changes into x squared minus 1 to which power? Which power? Anyone, please? We're differentiating this function now. What will be the power of x squared minus 1?
Would it be 1?
So let's review the rule. The top function prime times the denominator minus the top times the denominator prime over the denominator squared. We have to square the denominator.
So 4.
Exactly. Awesome. That's it. Perfect. So now we go back. Can anyone give us x squared plus 1 squared so I can put it here? The numerator square, the numerator prime. That's what I meant, not squared. Sorry. The numerator prime.
2x.
Excellent. Times the denominator minus the numerator times the denominator prime. And the problem here is that we do not know how to do this yet. So they messed up. This problem should not be here. Should be in the next section. But since we started it, I have to tell you the answer, because we have to finish it up. So I'm going to explain this on the side. So remember what I said when we differentiate x to the nth power, because it's plain x, the formula is n times x to n minus 1. But, like in this case, if we have a function to a power, this is called the chain rule. But we can talk about the chain rule in here because we're not there yet, but I have to finish the problem now. We started it. So this is the same formula. N comes down, f, the function, to n minus 1, but there is a big difference. Here we did not write x prime, the inner function prime. Why didn't we write x prime? But here I have to write times f prime. How come that we did not write x prime here?
Is it because the second one is the function where the first one is
It's
just
because this is 1. Because x prime is 1. That's why we omitted this. We didn't write it because it was 1. But here it's not 1. So I can no longer omit this. It's the inner function prime. So now I need to show you how to differentiate x squared minus 1 squared. Yes, we can distribute and then expand and then differentiate, but who does that? Nobody. Okay. So based on this, x squared minus 1 squared prime is 2 comes in front times the function to 2 minus 1 times the inner function prime, which is 2x. This is this. This is to n minus 1, 2 minus 1, power 1. And this is the inner function prime, which is 2x. So the answer is 4x, x squared minus 1. This is what I have to put there. So 4x times x squared minus 1. So now, what happens next? We have to fully simplify this. We can't leave it as is. So the simplification is not difficult, but it's not trivial either. So I have to come back to this. I'm going to write it one more time so I can explain what happens. So we had, you don't have to copy it again. I need to copy it so I can explain what I'm doing. So there is a minus in front. There is a 2x, x squared minus 1 squared, minus x squared plus 1. Since this is a product, I'm going to write times 4x times x squared minus 1 over the denominator to the fourth. Okay. See what happens next. There is a 2x in here and a 4x in here. So the common factor will be 2x. There is an x squared minus 1 squared and an x squared minus 1 in the other term. So an x squared minus 1 will go outside. Which will eventually, we're not there yet, but will eventually go away with one of those factors. You have to factor out first before you simplify. Okay, so let's see what is left. 2 is out, x is out, one of these two is out, so one is left inside. This is out, x is out, but there is a 2 distributed here. So minus 2x squared minus 2. Let's do this one more time. So 2x is out. One of these two factors is out, but one of them has to be in. How do I know? Well, when I multiply these, I have to get that. 2x times x squared minus 1 times x squared minus 1, I get that. Now, this is out, because it's right here. X is out. And the 2 is out. 2 times 2 is 4. So only 2 has to be distributed to x squared. And 2 distributed to 1, but they are both negative because of the negative in front. I already simplified this. And the next step, negative outside, 2x outside, negative x squared minus 3 over x squared minus 1 to the third. I saw that some of you in the homework are still expanding the factors in the denominator. It's a waste of time. You shouldn't do that. Please do not expand the factors in the denominator. I will factor out a negative 1, which will terminate that. So I have 2x, x squared plus 3 over x squared minus 1 to the third. Again, this problem does not belong in this section. We're not there yet. It was a good practice. We're going to talk about the chain rule anyway. It's the biggest of the rules. Okay, so let's talk about the tangent line and the normal line. And that would be good enough. Then I would like to talk about something like this. So let's talk about the normal line first and the tangent line. Let's choose a problem, please, to determine the equations of the normal line and the tangent line.
37.
Okay, very good. Let's work on to 37. In 37, we have y equals 3x over 1 plus 5x squared, and the point is 1 comma 1/2. So they're asking us to find the equations of the tangent line and the normal line. That is the question. Okay. So not a big deal with the tangent because y minus y1 equals the slope times x minus x1, where I know that x1 is 1 and y1 is 1/2, and I need to determine the slope. And we know how to determine the slope. Anyone refreshes our memory, please? How do I determine the slope of the tangent line? How do I get this? We did something like this a few minutes ago, maybe half an hour ago. How do we determine this number? Anyone, please?
We find y prime.
Yes, we have to find y prime, and then we will plug in x equals 1. Exactly, that's what we need. But first we have to find y prime. Awesome. Again, I notice there is a factor here. I'll leave the 3 outside. I don't want to deal with it. It can patiently wait. It doesn't have to be involved in this if it's a factor. If it's not a factor, then I have no other choice. No choice. But it's a factor. It can wait patiently. So the top prime, I know you're going to say 1 times 1 plus 5x squared minus the top times the denominator prime over the denominator squared. Can anyone differentiate this? And I will put it here.
Is it 10x?
Yes, of course. Perfect, 10x. So then 1 plus 5x squared minus 10x squared over 1 plus 5x squared squared. Or negative 5x squared plus 1 over 1 plus 5x squared squared. I need to plug in 1. So y prime when x is 1. 3 stays outside. Negative 5 plus 1 is negative 4. 1 plus 5 is 6. 6 squared, 36. I'll simplify and I get a 12. And I'll simplify and I get negative 1/3. So this is negative 1/3. Any questions so far? So I have the, yes? Where? Where do we go back?
The second way.
Here?
Yes, y prime, yes, right.
So 1 plus 5x squared, this is negative 10x squared. The 5 minus 10 is negative 5x squared, and plus 1. And when I plug in 1, negative 5 plus 1 is negative 4. 3 is outside. And 1 plus 5 is 6. 6 squared, 36. I simplified 3 and 6 and 36, and I got 12. And negative 4 and 12 by 4, and I got negative 1/3. Is that okay?
Yes, I'm with you now. Thank you.
Thank you. So y minus 1/2 equals negative 1/3 x minus 1. This will give us the equation of the tangent line. So I distribute negative 1/3 x plus 1/3 and plus 1/2. So 1/3 plus 1/2 has denominator 6, and this is 2 and 3. So 2 plus 3 is 5. So negative 1/3 x and y. This is the equation of the tangent at the given point. Now, for the normal line, If this is the equation of the tangent, this will be the equation of the normal line. If the slope of the tangent is negative 1/3, what is the slope? So this is M1 and M2. What is the slope of the normal line? What is the relationship between the slopes of two lines that are perpendicular? If this one is,
Opposite reciprocals?
yes, so if this one is negative 1/3, this must be 3. So that the product is negative 1. That's all we need to do. I still have y minus 1/2, but the slope is 3 for this one. That's all we needed to do. Determine the equation of the normal line, which is, so the relationship between the slopes of these two lines, if they are perpendicular, the product has to equal negative 1. This is how I like it, but you may say exactly what we were all taught. If this is negative 1/3, this is the negative multiplicative inverse of that. So now all I have to do is distribute and add 1/2. So y equals 3x minus 3 plus 1/2. 3x minus 3 plus 1/2. So this is negative 6 plus 1, negative 5/2. So y equals 3x minus 5/2. This is the normal line. It's called normal because it's perpendicular to the tangent at the same point, of course.